Hi, everybody. It's Dr. Chabot, and this is going to be our introduction to the lab video. You have received, hopefully, a notification that you were added to a lab group in your Google Drive. So if you use your RIT email and then your g.rit.edu account to get into Google and then go to your drive, then in the shared drives, so the shared drives, you'll see lab folder. So you're either group 1, group 2, group 3, etc. That's going to be where the document are, the shared documents, either a Google Doc or a Google Sheet that you're using to complete each lab in groups. And so if you have trouble navigating that or finding that, reach out to me via Discord as soon as possible. Let me know, and then I will make sure that you have access. I did try to assign the groups based on your preference in terms of synchronous or live, and as well as whether or not you tended to like to get things done early or day of. So let me know if you have any questions or concerns. Each group has between about 5 to 7 people in it. Okay, so what I'm going to do is I'm going to go ahead and share my screen, and we're going to talk for a second about what to expect for the labs. So first of all, you might have something like this. When you click on your group lab, you should have something that lists the labs, lab 0, lab 1, lab 2. And then if you click on each one, and you can see your group members based on going up to the shared icon. If I click on one of them, then in this one, you can see that there's a Google Sheet and a Google Doc. If I click on the Google Doc, then you're actually going to write your responses in this Google Doc as a group. I'm able to see participation in this. So I'm able to track participation and make sure that everybody is doing their part. And then you're actually going to use the videos in Pivot Interactive. So this has all the directions for what you need. And then each person is going to sign up for one sort of set of measurements. And you can see that each set of measurements is different. So everybody's taking an individual set of measurements. Note that in this Google Doc, things are labeled as either individual or at the very end, group. So everybody individually contributes to their row of the data. And so then there are things that are labeled group discuss, and the group discuss are where you will have some kind of discussion, either asynchronous or live, in order to answer these questions. In this first lab, I am even asking, how did your group discuss this, right? And again, I can see who's participating on these Google Docs and can make sure that people are getting the work that they are credited for. So at the end, once you go through and do all of your parts, either individual, again, lots of individual parts for all the data taking, and then the group questions bring together everybody's individual data. Then when you're done, you can just print this to a PDF, and every person's going to submit their own to the Dropbox. Only the people contributing will earn credit. So you're going to contact me with issues. So if you have somebody that doesn't even start the lab until an hour before it's due, then that isn't working for the rest of your group that maybe is done with it. You need to contact me. I can try to move them into a different group, or maybe they have to do, something else to make up the lab. It won't penalize your group to have a non-participant, if that makes sense. So contact me with questions. We'll kind of navigate that as we go. Okay, so that's the format of the actual reports that you should all have access to now. They all do require using Pivot Interactives. And so part of this first lab that's going to be due on the the Wednesday normal deadline for labs will be to get used to Pivot Interactives. When you go to Pivot, if we look at, for example, Lab 0, it's basically where the videos are housed. And these videos allow you to play real life motion and then use measurement tools then where we can see from this video position on the ruler, this movable ruler that I can use, position as a function of time. So for example, this one in the video, it says to measure from, in the directions, it says to measure from the very front of the ping pong ball as it leaves. So I would say here, you can see this is frame 43. It's at 0.01654 seconds. And I can use the arrow keys. Arrow keys will let me advance frame by frame. And then I'd be able to make a measurement of the front of the ping pong ball's location at another time, and again, and again, and again, and again. And you are able to zoom in so that you can get more details sometimes than the smallest measurement shown on the ruler. So definitely use not your phone. Use the largest screen that you have and make use of the zoom feature in order to get careful measurements. I do require, when I go through and look, I do require some people to retake their measurements if they are not done carefully and with large enough screen. As another example of the first one that you'll be analyzing, we have here a real life
6, 5,
rocket
4,
launch.
3.
And I'm just going to forward to the part where the rocket's actually moving. So here the rocket's starting to move. I can put in the ruler, and here we actually have 2 different rulers of 2 different colors. So you can pick whichever one seems to work better for you. And then you can click the timer tool, and there's instructions for how to do all of this in the lab. And again, I can zoom in. So you're zooming in, very important. And if this one is saying to measure for the tip of the rocket, literally move the ruler over so that it's over the tip of the rocket, right? There's no reason to not do that. And then you can set it up and say, okay, I'm going to start here. Let me start at 0. And then it says to reset this time here to 0. So I can go ahead and hit reset. And then now I can advance frame by frame by frame and get a position as a function of time of this rocket as it's moving. You can see the units are on the scale, and you'll get position as a function of time that'll allow you to then plot that. You'll be taught how to make graphs and fit them to get then the velocity as a function of time. And so then we have these values here. And again, notice that when you zoom in, you can get resolution where you can not having to be limited by the scale that you're given, and you can then see a lot better the actual motion of the rocket. Okay, so the key tricks there are the arrow keys, forward and back, and the zooming in. If I'm trying to make measurements zoomed out, very difficult, but the zooming in on your screen will help quite a bit. You'll then be putting in your own individual data and graphs. There's some tutorials in the labs themselves to help you figure out how to make those graphs. And after this first lab, everybody should be feeling pretty good about Pivot. Pivot will be used for all the labs, so you should reach out with concerns. And it will be used for a midterm and final project. So it's very important that you get used to using it to make measurements on a video, and that you use it, and that you get used to using it to do the analysis. So the Google Sheets aspect of being able to collect data, make a graph, fit a graph, and interpret the graph is also just as important for our long-term learning goals. Okay, so the 2 components there are Google Drive, where you have access to you and your group's collective lab report that has the instructions, and then Pivot Interactive, where you will actually be making the measurements, and everything is very clearly labeled what's individual and what's not. And again, if your group is struggling with a member whose time commitment is different than yours, and your group is finished and somebody hasn't started or something like that, or maybe you haven't even heard from one of your group members, you need to reach out to me and I will help you with that. And again, you are not penalized for having a non-participatory partner. So just keep me informed and let me help you. And hopefully you feel that these are collaborative in that you're all making very similar measurements, so you can help troubleshoot each other and say, that doesn't look quite right, right? G isn't 2.5 meters per second squared, and help troubleshoot together, come back, bring all your data together collectively, but that there is individual accountability for every person's contribution to the labs. Great. Good luck. Reach out with questions. The main deadlines for starting this course are on Sunday. And again, you are encouraged strongly to be working ahead in this course and letting me know when you have any questions or concerns. Take care.